All right, lesson 4.2. We're going to work now on dividing monomials. So let's take a look at some key terms. First of all, we're looking at quotient rule. If our last lesson talks about product rule and power of power rule, here's the quotient rule. Now, as we saw before, we looked at shortcuts after making observations. We'll do the same today. Notice that if I have 5 to the 4th power, 4 to the 5th power divided by 4 to the 2nd power, if I wrote it out, this is the best example to start with. If I wrote it out, 4 to the 5th power, actually let me write this out first, 4 to the 5th over 4 squared. This is what we're looking at, and that's what division means right here. Well, if we're going to write this out in expanded form, it would look like 4 times 4 times 4 times 4 times 4 over 4 times 4. And when you have the same number or letter over each other in a division problem like this, we can cancel them out. And what we're left with is 3 4s remaining. And that means that we would end up with 4 to the 3rd power. So what is the shortcut? Well, if you make an observation here, you'll notice that if you started with 5 and then you had 2 below, you would just subtract the 2 powers and you end up with what you would end up with if you did it longhand. So again, in the shortcut version with letters here, if you have x to the m divided by x to the n, or if I write it this way, x to the m over x to the n, you would take the top power and minus the bottom one. Now, subtraction order matters, so you have to make sure you take the top one, in this case the exponent of m, minus the bottom power, which again in this case is n. There's a nice rule here that makes your work a lot easier if you notice it, and that's that anything to the 0 power is always going to give you 1. So, except for, of course, if you had 0 to the 0 power, then it doesn't work. That's what this means. You cannot have that. So anything, if I have x to the 0, I get 1. If I have 10 to the 0, I get 1. So no matter what it is, except for, of course, unless it's 0 to the 0 power, we would always get 1 as an answer. Negative exponents are a notational item that actually means something else. If we have 4 to the negative 2 power, it actually means 1 over 4 to the positive 2 power. So the way I like to look at it is that if you see a negative power, it's telling you that it's in the wrong position of a fraction. So for example, 4 to the negative 2 over 1 is telling you that 4 to the negative 2 should not be where it is. That's not what I wanted to do, hang on. So this to the negative power tells you that it's in the numerator and it should be in the denominator. So to fix it, meaning to write it without a negative exponent, we would change locations. So the top would just be a 1 because there's nothing there anymore, but we have to represent it as a 1. We can't write 0. And down below, the 4 squared reappears. But now it has a positive exponent, and we can calculate it as 1 over 16. So let's see if we can apply some of these. Alright, so first of all, let's look at the a's. A to the 3rd over a. Now I'm going to do this longhand for you just to see why we don't do it longhand. Now again, a to the 3rd means 3 of them, b to the 5th means 5 of them, a to the 1 is just a, and b to the 3rd is 3 of them. Now the a's cancel here, 1, 2, 3 b's cancel, and you're left with 2 a's on top and 2 b's on top and nothing below, but we'd have to write a 1. That's the same as a squared and b squared. Now, what does that mean? If I take a to the 3rd over a, it's a to the 3 minus 1, because that's a 1 down here, and b to the 5 minus 3. That gives us a to the 2 and b to the 2. Same result. That's not a negative power, by the way. That's a. This is nothing. A squared, b squared, that's the same thing as here. So a shorthand way of doing it and the longhand way of doing it. Let's try another one. Now we have 4 divided by 2. Well, that's going to be 2. That's pretty easy. X to the 1 over x to the 1 is x to the 1 minus 1. If you notice, they'll cancel out. And then y to the 7 minus 3. So 2, x to the 0 power is just 1, right? So it disappears. And 7 minus 3 is 4. Okay, let's try another one. X to the, again, top number, a top power, 3 minus the bottom power. And then y to the 4 minus 1. So we get x to the 1 and y to the third. I'm just subtracting. K to the 7 minus 4, m to the 10 minus 4, and p to the 1 minus 1. And that will give us k to the third, m to the sixth, and p to the 0, which is 1. Alright, now we're going to talk about powers to powers again like we did in our last lesson, but we're going to incorporate division. Now let's take the power of, let's look inside the parentheses first. Nothing can be reduced. So, as you mentioned with power to a power rule, we distribute. And the only thing that's changed here is that we have a denominator, but that also is affected by the power of 2. So this becomes 3 squared p to the, now the same rule as last lesson, you multiply powers when you have a power raised to a power. So it's p to the sixth over 7 squared. And that gives us 9 p to the sixth over 49. And I believe that's not reducible. Alright, again, look inside the parentheses. Nothing can be reduced, so we go ahead and distribute that power. And everything gets affected by it. So we have 3 to the fourth, x to the, now we multiply powers because of power raised to a power, so 12, y to the 24th over 2 to the fourth, and z to the 36 power. Now again, you can go ahead and take 3 to the fourth and 2 to the fourth, but as is, that's fine at the moment. Alright, again, distribute the power to everything inside the parentheses, and we get 3 to the third, x to the 12th, and 4 to the third. Distribute the 3, the power of 3. But again, I should mention this. Always make sure you and see if you can reduce the inside of the parentheses first. Nothing can be reduced, so that's why I'm going ahead. 4 to the third, x to the 9th, because 3 times 3, over 5 to the third, and y to the 12th. Now one nice thing here, we talked about this, if I were, this is one piece, one fraction, all to the 0 power. So if I distribute this 0, everything will eventually be to the 0 power. So I know from my 0 power rule, or 0 exponent rule, that anything to the 0 power is 1. So I don't even have to distribute that because I know that everything to the 0 power is going to end up being just 1. Alright, so my next one here, now y to the 0 is 1, so that disappears. So we're left with x to the 5th minus the power of 3. And we get x squared. Alright, so now we have a to the 3 minus 1, b to the 2 minus 1, and c to the 0 is gone because that's just equal to 1. So that gives us a to the second and b to the 1. And you don't have to write the 1 power, but in this case I'm doing it just to clarify. B to the 1 or just b are the same things. Here we have everything inside the parentheses to the 0 power equal to 1. Now here's where it gets a little interesting. We haven't talked about this yet in a particular example, but here is a negative power. So let's look at this. Notice all the variables are different, so we can't combine anything, but we said before that anything that has a negative power is telling you it's in the wrong position. And we said to fix that, we would just move it to the other position in the fraction. And there's only two places to be, numerator or denominator. Now, the p to the fourth is okay. That is a positive exponent. However, n to the negative fifth is in the numerator, and to make the power a positive 5, we should move it below. The r to the negative 2 is in the denominator. To fix that, we move it to the numerator, and then the power becomes positive. Notice I did not put a negative or a positive in front of the number or the letter itself, because we're not talking about the letter itself, we're talking about its exponent. So the exponent changed signs. Next one, well, let's take a look at 2 divided by 10 can reduce, and we get 1, and then a 5 down below, because 2 goes into 2 once, and 2 goes into 10 5 times. Now I'm going to fix this before I do anything else. There's two ways you can approach this. I'll do it this way first. I have a squared. I have a to the negative 3. I'm going to move that up, and it becomes a to the positive 3. I have b to the third, and b to the negative 1 in the denominator. I'm going to bring that up, and it becomes b to the positive 1. Now I have c to the negative 5. I'm going to move that below, so it becomes c to the positive 5. And c to the fourth is fine. It has a positive exponent. It does not need to be moved. Now, I still have 1 on top, 5 in the bottom. I now have a to the fifth. Notice I'm adding exponents now. B to the fourth. And down below we have c to the ninth. Now there's one other way to do this, and I'm going to show it to you in case you would prefer to do that. Alright, I have 1, and again 5 below. If I use our division rule, it's quotient rule, we would take top, and it would be 2 minus the bottom exponent of a, which is negative 3. And b would be 3 minus a negative 1. And then c would be negative 5 minus 4. Every time you subtract exponents, your answer is in the numerator. But look what happens. 2 minus negative 3 does become 5. b to the 3 minus negative 1 becomes 3 plus 1, so you get b to the fourth. c is going to come to negative 5 minus 4 is negative 9. Now notice that my c to the negative 9 is still negative. It's telling us that it's in the wrong place, so I would put that below, and it would become c to the ninth. So the negative exponent told us that that needed to be. Alright, let's take a look at this one now. I'm going to do these fast. So notice the w's will cancel, because it's basically 1 minus 1. Our v to the negative 2 should go below, because it has a negative, now it's positive. The y should go above. First of all, we have x squared, that's okay. And now y to the fifth. We're just fixing the powers. Now 32 divided by 4 is 8, and I want to just put that on top right now. I have 8 to the negative 8 to the negative 8 over a to the 3. Now negative 8 minus 3 will look like that. b to the fourth minus 6th is that one. And c to the negative 5 minus a negative 2. Alright, that's all over 1. Now let's clean some things up. We have 8. Now negative 8 minus 3 is negative 11. B to the 4 minus 6 is negative 2. And C to the negative 5 minus the negative 2 is plus 2, so negative 3. Now let's fix it. Right now it's all over 1. So this becomes 8 all over A to the 11, B to the second, and C to the third, because we had to move them to make them positive. And this ends lesson 4.2.